Good morning, one and all physics students, and welcome to another episode of Physics. It's Mr. Finn coming at you again from neighborly Northville. And today we're talking about the motor. Yesterday I demonstrated how a motor worked, and I put the power supply lines right on each of these two connectors here. We took a little bit of time to start the motor up, but once we got that motor running, it ran pretty quickly. So let's take a little more in-depth look, and I know I'm going to show you the video on how a DC motor is constructed, but I do have a couple of things I want to share with you before you see that video. Number one, let's talk about the direction of the current. Coming down, let's say my current direction is coming in through this thing here, right through the little brush. Brush attaches to the metal part on the spindle. That spindle connects to the front coil, and that coil wraps around, goes close to the other coil in the same direction, same type of wrap, and that coil connects back up to the back brush and out, back brush, and out through this terminal here. Now, they're going to show you that much clearer on the video coming up, but a couple of things before you see that video. Number one, we only need to watch through the 3-minute, 46-second mark. After that, they talk about back EMF. We really don't need to talk about that. Secondly, the term spring-loaded commutator brushes. That is this. These are the brushes. And you saw me, during my working with the motor, try to adjust the tension on the brushes. So spring-loaded commutator brushes are springs that push the brushes onto the connective plates. That's all that is. The field coils. The field coils. So the field, right, that's the two magnets I had on either side of the actual coils. The field coil. So what they did was, instead of having these two magnets here with a established magnetic field that's constant, they had coils here producing a magnetic field. So don't be afraid or concerned when you hear the term field coils. And lastly, the term load. They said that the motor drops drastically with the load. That means, what are you trying to power with this motor? For example, if I had a motor like a washing machine, and I have a big load in the washing machine, too much for the motor might stop working. It might actually overheat, and then we would ruin the motor. So we don't want to do that. So we just got to be careful of some of these terms that are being used in our motor video. Before I let you go on that video, let's just take a basic look at the difference between motors and generators. We'll go to the big board. Okay guys, before I let you get into that motor video that's very exciting, let's look at basically what a motor is. Yesterday we had the idea of generators. They used a moving arm through a changing magnetic field to produce electric current. So generators always produce electric current. But what do motors produce? They produce moving arms, mechanical kinetic energy. Moving arm is my output. So a motor is simply using electric current through a changing magnetic field, producing a moving arm. And in this case, with our motor that we showed the other day, the moving arm was the spindle moving around and around and around. A motor like your car, the output would be the movement of the drivetrain, the axle, or the drivetrain turning the axle. It allows your cars to turn their wheels. Pretty cool stuff. Okay guys, let's check out this motor video. And then remember, keep an eye on your Google form coming out tomorrow and get those homework questions done. If you need me, I'll be available for the Google Meets. And as always, if you have extra questions, please email them in and I'll try to address them. Okay guys, have a great day. Watch that motor video. Remember, right around 3 minutes and 46 seconds, you can shut it off. All right, have a great day.